Welcome back. Now we're setting our actor's location on begin play using SetActorRotation. Now I'd like to change the rotation as well. So dragging off of begin play for BP item, I'm going to type SetActorRotation. And we have a SetActorRotation node. Now this takes a rotator. And a rotator is much like a vector. It has three components. And if we hover over them, we'll see that the x is the roll value, y is the pitch, and z is the yaw. So if we set our actor rotation to 0090, for example, then the yaw for our actor will be 90. And if we press play, we can see that that yaw has rotated the actor about the z-axis by 90 degrees. And of course, if we replace this with -90, then when we hit play, we'll see it's rotated the other way. So this is pretty self-explanatory. Now we do have this option, teleport physics. If we hover over it, we see that it's a Boolean, and by default it's false. I know that because the checkbox is unchecked. If I check it, then teleport physics will be true. I'm going to uncheck that. Now the pop-up says whether we teleport the physics state, if physics collision is enabled for this object. If true, physics velocity for the object is unchanged, so ragdoll parts are not affected by change in location. If false, physics velocity is updated based on the change in position, affecting ragdoll parts. So if we had parts attached to this actor which are using physics, such as chains or ponytails or ropes and things like that, then this change in rotation would affect those things. They would flop around and dangle, but teleport physics will simply teleport the actor's rotation, and those floppy parts will not flop around in response to the movement. So that's what that means. Now I'm going to delete that node and hop back into my C++ project. And setting the actor rotation is just as simple as setting the location. We can call SetActorRotation, and the pop-up here says one of two. So there are two versions of SetActorRotation. One of them takes an fquat, which we haven't learned about yet, and the other takes an frotator, along with an optional eTeleport type. So rather than a Boolean, which is what we had in blueprints, this is an eTeleport type, which is an enum type that we'll learn about later. So we can pass in a temporary frotator. This is what frotator looks like. And frotator has a constructor overload that takes three values. So we can pass in, say, 0.f, and if we enter the first comma, we'll see that it's recognizing that we're going to use the version that takes three values, and we'll see that they're actually doubles. So the first is the pitch, and the second here is the yaw. So I can enter 45.f for the yaw, and for the roll, I'm going to enter 0.f. So now we're rotating our actor by 45 degrees, and that's going to be clockwise if we're looking down on the actor. So let's save everything, and we'll hop back in the editor and hot reload. And now we can press play, and we see that our actor has rotated by 45 degrees about the z-axis. So setting an actor's rotation is relatively straightforward, and it can be used in a number of ways, as we'll see throughout the course. Great job! I'll see you soon.